All right. Welcome to the session today. I'm Nirmal Mehta. I'm a principal specialist solution architect with AWS focused on containers. And I'm excited to present a topic that's near and dear to my heart around observability with Sundar. And let's get started. Let's get into it. So I talk to a lot of customers. And to understand what is really driving them to start adopting and modernizing their applications. And our customers, most of the time they say they want from us is they want to innovate quickly, compete in a global market, and deliver value to your customers, to their customers. They want their teams to deliver products to customers as fast as possible. They want their applications and infrastructure to be reliable, highly available, and scalable. They also want the highest security and isolation for their workloads. And on top of all of that, they wanted to do it with the lowest cost of ownership possible. Do any of these resonate with you in this audience? Yeah. But there's a little twist to this. So in getting to this, they move their workloads to the cloud, they migrate there to achieve these goals. But then they go to reInvent, and they see a keynote, and our CTO says, everything fails all the time. What gives, right? Why would our CTO say that? Well, this quote is at the center of what drives our engineering practices at AWS, the services and architectures that we build our services on and drive our services from, and the well-architected core that we drive for our customer solutions and help them achieve on the cloud. So what's behind this statement? It's the idea that we live in this universe, and in this universe we have this thing called entropy, which means that over time everything just degrades. And from that essence comes this statement: everything fails all the time. So regardless of your setup, regardless of your architecture, you have to keep this in mind. We keep this in mind for the services that we provide to you in terms of static stability, multi-AZ architectures, cross-region, et cetera. And we help you achieve that as well on top of our services with best practices and well-architected reviews. But regardless of your setup, you still have to have something there, and that is observability. So not having observability introduces risk, which can cause interruption in your services. And having observability is foundational to knowing when things are failing and to respond correctly. But observability matters both for the infrastructure side and your operations. As we're responding to that idea that everything fails all the time, that's going to push everyone to think about distributed application architectures, multiple AZ architectures, splitting their monoliths out to microservices. And with that, from an operational standpoint, you're going to get larger amounts of dynamic infrastructure. You're going to want to trace your services from one service to another in large dependency maps. And you're going to want to deep dive into various layers to understand what is failing or where the problem is. But observability is not just critical for operations. It's also foundational to a well-architected system that delivers business value. And this is the key to the talk today in my thinking, and Sundar can maybe disagree or agree a little bit later. But the word in the title of today's talk that means the most to me is correlate. We want to make sure that you are successful in your systems by delivering business value and correlating that to what your operations and infrastructure of your systems look like. And that is the essence of good observability practices. So with observability, you can also enhance your customer's experience. You can find out what their actual experience is like and what's happening from their point of view. You can improve the business uptime and reliability. Business value is derived from good customer experience and service availability. And you can also respond to the feedback and behavior of users. So going from a more reactive state, meaning just responding to changes in your system or failures or degraded performance, to becoming more proactive from a business and holistic standpoint is the essence of observability from operations to business value. This map here and achieving these goals leads a lot of our customers to adopt container services as their primary service that they build their new modern applications on or migrate their existing workloads. We have lots of customers that have achieved this kind of success in driving these business values with the operational gains that they're looking for in terms of speed and reliability, security, et cetera. An example is Match. So Match.com was migrating workloads from on-premise to AWS container services in AWS regions. And while they're going through that migration, they needed to ensure that their system was reliable and performing well, and that they had visibility across the whole entire system, both from on-premise as they're migrating to the cloud on top of container services. So the complexity of that, it's a little bit daunting. They leveraged AWS container services as their foundation for their modern their migration and their modernization. And on top of that, they used App Dynamics to create a holistic view of their whole entire system, both on-premise and in AWS services, as that migration happened. And they were able to get that full picture. And with that, they achieved very good performance and no downtime with respect to that migration. And they say that they were able to get this holistic view, and it was critical to migrating those workloads. Another one is JobVite. JobVite achieved comprehensive observability as well of their entire development lifecycle. And while they were doing the same migration, they just had 6 people, and they were able to migrate all of their workloads within 6 months with just 6 people. Observability was crucial to being able to achieve that. Their mean time to repair and early detection of issues while they were doing that migration went from days and hours down to minutes with their use of App Dynamics and AWS container services. So, when we're together, AWS and leading partners like App Dynamics, together with our services, we can achieve this amazing overall business value and operational excellence while you, as customers, modernize and migrate your applications to achieve those goals. So with that, I'd love to introduce Sundar up to stage to show you how to do it. Knock it out. Here you go.
Thank you. Thank you. Good partner, when they tell you customer stories, joint customer stories, the way Nirmal just talked about Match and JobVite, right? It's terrific to be able to build solutions and products together in close partnership to solve customer problems. And that's what we've been doing with AWS. Now, he's given the perfect setup. Oh. All right. Wrong button. Okay, so he's given you a setup about what it takes in terms of observability and the criticality of observability in cloud-native environments. When we go out and talk to customers, jointly or even separately, they talk about 3 big areas where cloud-native observability bothers them. First thing is this idea of disconnected silos of data, right? Whether it is proprietary solutions or open source solutions, many of them come with a biased point of view based on the legacy that they're coming in, right? Hey, look at my logs, use my logs for root cause analysis. Oh, by the way, let me glom on some APM on top of it. Hey, look at my trace-based data, let me glom on some logs-based analysis on top of it. What it leads to is we as users have to deal with these discontinued silos of data, and it provides incomplete visibility, and it forces users, the DevOps teams, the SREs teams, the CloudOps teams, to literally go sometimes from tool to tool, sometimes from tab to tab to tab in a single tool, and do what I call as human correlation, right? So instead of the system providing correlation for you and trying to help you get to that root cause analysis quickly, it forces us as users to basically take all of that information and either put it in an Excel sheet or use our human brain to do correlation, which is why correlation across the stack and up and down the stack in some ways is the most critical need that we hear from our users, right? And the reason we actually launched AppDynamics Cloud earlier this year, middle of this year, was to solve that problem, right? We took a clean sheet of paper and said, hey, given the problems, what we're hearing, and more importantly, given where this industry is going, how do we solve for this differently? So we made 3 kind of core principles, right? First, it needs to be purpose-built, of course, for cloud-native architectures at cloud-native scale. That's a given. But the most important thing is, how do we embed correlation of the full stack up and down across different melt types and up and down the entire technology stack as a core principle? And we have a very opinionated view of what that stack is, and we will talk about it as part of this talk. Second, observability in general, technology in general actually, but observability in particular, has been moving towards open standards in a big way, right? And traditionally, proprietary solutions have been proprietary for that nature, right? They haven't embraced open standards. This time around, we basically said, no, the entire platform, the API surface area, everything should be OpenTelemetry compliant. So OpenTelemetry is at the heart of the solution. And what that means for you all as users is, let's say you have a certain application out there which is not instrumented, which is not observed by one of our solutions. It allows you to be able to instrument that with OpenTelemetry and really get the same kind of correlation and business insights that instrumented applications get, right? So it really is about freedom and choice. And the last one, of course, judicious use of AI/ML in order to get to faster RCA, right? These are kind of the 3 core principles of how we've thought about when we have brought out AppDynamics Cloud. And I'll get into each one of these areas and specifically the use cases that you all will be able to solve today with AppD Cloud and what we are doing in the immediate future, right? But before that, I want to take a step back, right? Nirmal talked about what it takes for customers to move their workloads onto public clouds, how they have to deal with hybrid clouds. And what we as an industry are realizing is there is a need for a full stack observability architecture foundation for the entire platform in some ways. This is Cisco's prescriptive vision in some ways, right? This is how we are thinking about this overall problem. We have a large vision for full stack observability. In fact, early next year, we're going to do a preview of what we are calling as the Cisco FSO platform. Think of this as a sneak preview that we are offering you. This chart is absolutely an eye chart. If some of you attended a talk yesterday on the FSO platform, you saw Carlos talk about a whole bunch of this. But I'm going to give you a quick view on this one. If you take nothing out of this, there are 2 parts to it, right? The platform that you see in the center, it has cross-melt as a key principle. So what that means is instead of data siloization between metrics or events or logs, how do we bring all of these different melt data types and deliver insights across the board? That remains at the heart of it, right? But what that allows us to do is really open up multiple use cases that you see in these services. For example, I was talking to one of our customers. I was talking to the head of security, and they came in and said they saw a pattern over the last 12 months. Every time they had a security vulnerability, it was highly correlated with performance issues. Sometimes the performance issues were leading, or sometimes they were occurring at the same time as a security vulnerability. That brought in the question, which is, hey, if there is a way by which, with the same data, can we deliver both security insights as well as performance insights, how does that help? And the head of security was like very pleased. He was literally talking about in their organization, they were moving from traditional DevOps and SecOps into a DevSecOps organization, right? And he was getting that opportunity, and he was really worried about the fact that his different teams were being forced to look at different tools. And this was, when we talked about this vision, they were like, that's exactly what we need. We need that level of single pane of glass view across all of these. And the way to do that is by having a common platform across the board. And you see this at every level, right? Whether you see at the app level, whether you see at the network monitoring level, the internet monitoring level, or even when you go for something like infrastructure cost management, right? But all of that needs to be tied as part of the business context, right? And that's literally the top layer of the overall vision. So let me go a little bit deeper on the FSO platform. The goal for the FSO platform is, as it says, a single platform for both Cisco and third-party application. You might ask why, right? One thing that's really, really clear is observability is becoming foundational for the way we run services, whether it's on public or on hybrid clouds, right? And in order to do that, you need a single product platform which acts as an integration platform where you have various different product silos coming together and you can stitch a common experience on top. Second, you want to be able to troubleshoot deeply and do things like interesting things around AI, ML, and anomaly detection, which uses inputs from each of the different data types. A classic use case, again, a different financial customer that we were talking about, they have an idea of actually doing fraud detection, right? Fraud detection based on melt data. We're like, how does that compute? This melt data is operational machine data. How can you do fraud detection based on it? What they have found out is there is business logic that they see that when there is impairment of specific operational components anywhere in the business context, if they're able to tie it as part of the overall business dashboard, they're able to detect fraudulent behavior, which is seen in machine data, right? We, as Cisco, or any one of individual companies, don't have the ability to do that, but that customer does, right? They have the developers and the understanding of the business to be able to write that business logic. So what a platform like this allows you to do is really open this up to partners and customers so that they can bring their custom logic and write applications which, honestly, we as Cisco have not thought about it at this point in time. It's really, really exciting for us to be able to paint this vision and hear back feedback from our customers like, hey, we can go do this. That's extremely powerful, right? And the last part, the most important part, is traditionally, if you look at most of the other vendors or most other open source solutions in the space, they force the users to use tags or labels or any one of those to build relationships between different entities. That's a great way, right? Tagging is a very powerful mechanism, especially in cloud environments. But it should be, in our view, it should be additive, right? It should not be the way by which we force users to build these relationships. So we have what we call as an entity-centric model. And what that means is, and you will see this when I show the demo, is as data gets collected for a related entity, even if the same entity, like let's assume it's an EC2 machine that's observed by an OpenTelemetry collector, or you get CloudWatch data, because there's an entity-centric model in the center, the system, right, AppD Cloud and the FSO platform, they figure out that you can do that correlation directly and give a streamlined view. And what that means is two things, right? It does not have the burden that you all as users have to say that, hey, those two entities, that EC2 machine observed there and this CloudWatch entity is the same thing. The system figures it out. Doing it for one is easy, but imagine doing this for a 1,000-container environment, right, which is common today, or even more than that. So it really reduces the config experience. It makes getting to MTTD much faster, right? That's really the power of this idea of multiple sources, but single entity, right? And that's pretty much unique in the industry. The second bit, of course, is how do we make this extensible, right? How do we help each of the second, third-party developers to be able to build these new integrations, right? They can build their own custom integrations, and they can do it at multiple levels, right? One of our partners, they have a plan. They offer deep Kubernetes monitoring, right? It goes in much greater detail than what you would get with CloudWatch or what you would get even with us. And they wanted to partner with us. And the way they wanted to be able to reach the customers in a seamless fashion. Remember, the original challenge that we talked about is not forcing users to go from tool to tool in order to just get greater detail. So we took that to heart, and we have designed extensibility both at the UI layer as well as the underlying data model such that, let's say a partner like this who wants to provide deeper insights, they can extend the UI layer and bring their own data models such that within a Cisco FSO solution or their own screen, they'll be able to extend it and provide a seamless experience to you all in terms of users. So that prevents you all from having to go from one tool to another, right? We have taken to heart the 3 challenges that I talked about right at the start, and the whole idea of the platform design is to be able to ensure that we can solve for that, right? So that's the reason we have an FSO platform and this foundational platform to build all of these different Cisco FSO solutions. Okay. Let me talk specifically about the key use cases that we are solving for AppDynamics Cloud today, right? 3 key areas, right? One, as I talked a bunch about, business-focused observability, and I'll talk a lot more about it and what that means and why it's critical. Second is cross-melt troubleshooting, and third one is around AI-assisted root cause analysis. 3 pillars, right? And I'll get into each one of these. Cool. So first things first, right? The big idea around this is today in observability, lots of times we experience what I would call as alert fatigue because we get a series of alerts from different parts of the stack, highly uncorrelated. And more importantly, we do not know how to prioritize. And the big question is, what is the right lens to prioritize these so that you can react? And the view that we hear from our customers, and this has been something which we have traditionally believed in AppDynamics and delivered products against, is business metrics is the right way to do it. And what that means is, for example, for an e-commerce business, losing customers at the checkout is a problem, right? When you have user drop-off, that's a problem. It has real impact on revenue. If you're a loan origination service, right, one of our partners, they have a real problem if users are stuck anywhere in the journey during the online loan origination, right? Every business has a set of business metrics which they deeply care about. The question is, often those are in different silos, right? It's the business analyst community within the organization which is aware of those metrics. And when there's an actual issue on the service, the DevOps team and the SRE teams are blissfully unaware of what is the impact of this on the overall business. What we are allowing users to do is to be able to really decorate the overall observability experience using user journeys and through a business metric so that when that 2 a.m. Alert comes in, your SREs and DevOps folks are empowered to know what is the true business impact of it and what's the rate at which they need to react to it, right? Really focusing on empowering everybody in the organization with full business context is extremely critical and it's extremely powerful. And we do that with 2 different lenses. I don't know if you all checked out. Yesterday, we actually launched this idea of business transaction insights. There are 2 pillars to it. One is this idea of business transaction monitoring, and second is this idea of continuous cloud experience. I'll talk about each of these in a second. This was a launch that happened yesterday. If you want to see more about it, we actually have a booth down at the expo. You'll get an even bigger description from what I'll show off as a demo here, and you can actually experience both of these. So let me get to business transaction monitoring first. The idea here is reasonably simple in thought, but extremely tough to execute. The idea is when you're seeing a service performance issue or an infrastructure performance issue, how do you correlate that to business? How do you get a single view from business to apps to infrastructure, right? That's really the center point for this. And once you have this concept of a business transaction, what that allows you to do is really filter down on the experiences that are critical for the particular businesses. Failures happen all the time, as we heard. Some failures matter way more in terms of the business than others do, and this allows you to have that particular context, and you will see this in the demo too. Second part is, how do we use AI/ML to get the system to auto-discover the business transactions that are most critical to the business? Over a span of time, based on customers, we are able to understand, and the system is able to understand, what are the pieces of BTs that are critical, right? And lastly, of course, you're allowed to customize the BTs based on what is relevant to your organization. We've had this concept in the product in AppDynamics for a long time. What's new with AppDynamics Cloud is the ability, as I talked about, to be able to take open telemetry traces, i.e. traces from various different open telemetry sources, and be able to construct within the system what's most relevant for the overall business, right? So we effectively democratize this idea of creating a business transaction and a business journey. The second piece around continuous context is you'll notice the tabs that you see on the screenshot to the right? It talks about the business context, the end user context, the application, and the infrastructure performance. And you will see this in the demo too. It's a single view that you get so that in some ways, in some organizations today, especially in larger organizations, each of these tabs represent different teams, right? And one of the biggest challenges when there is an outage, I can talk about an airline that we work with. Their systems went down to such an extent that they had an issue about bringing new flights up in the air, right? So they were losing literally millions of dollars. And the biggest challenge that they had was their network team and their business team could not agree on where the problem was, right? And that back and forth alone led to multiple hours of wastage. And I've heard this from so many customers. And ultimately what happened was they all had to literally get into a war room to go figure this one out. That's a state that happens because there's not a single shared point of view. The whole idea of the continuous context experience is in a single page, how do we bring context across all of these different domains and the context remains relevant. If nothing else, it allows all of these different teams to have a conversation of exactly where the problem is, and then they can go RCA it and troubleshoot and move on. So it really compresses those multiple number of hours where just figuring out which layer of the stack is the issue becomes a problem, right? That's what continuous context gives. And the criticality is throughout the entire journey, it has the intelligence to figure out where you are in the overall stack and point you and help you follow the red, right? That's the power of being able to solve this problem. This was critical even in on-premise applications, but in a cloud-based application, it becomes extremely critical. Cool. All right. As we go kind of deeper into the stack, right, we spoke about the business. The next layer, of course, is using open telemetry traces. How do you deep dive into service issues, get a solid understanding, and figure out if there's a service issue, or more importantly, do service to infra correlation to understand if there are underlying infrastructure issues, right? The seamless ability to be able to see that is super critical. All right. So we talked about the business. We talked about what the business impact is. We talked about apps and service layers and being able to see what the underlying infrastructure issue is, right? That's kind of where we are next. So as part of the same product, we are able to give views into being able to troubleshoot Kubernetes environments anywhere, right? Whether it is on public clouds, whether it is on hybrid clouds, a single observability view across all of the different clusters, but more importantly, correlated between this. And we give an option, right? If you want to be able to do this without any agents, right? Without any collectors, as I mentioned, we can definitely suck in the CloudWatch data, and we can do this based on AWS CloudWatch alone. In addition, if you want additional insights, we can get an open telemetry collector in there, which provides deeper insight into the Kubernetes environments itself, right? And we make the management all of this super easy. And so what this allows you to do, again, going back to the original piece, is really get clarity from your user perspective, whether it's a Kubernetes layer issue or it's at a higher level, at a service dependency level issue, right? That kind of clear insights are something that you can get in out of the box. And more importantly, you can understand, get visibility into a whole bunch of different AWS services, and it's an expanding list that we look at it, not only purely from a metrics perspective, but from metrics, events, and logs. And we are able to correlate metrics and logs for this particular aspect, right? Again, what that allows you to do is, based on your cloud journey, you can figure out whether you want to be able to take advantage of just existing data that's coming in from the AWS Firehose, or you want to be able to enhance that with kind of open telemetry collectors, right? But all of this happens in a correlated fashion, going back to the entity-centric model that I spoke about, rather than you having to tie all of these entities together using things like tags, right? So getting the meld data from each of these different services and bringing them together is the power that we can deliver as part of this. Cool. So I spoke about what it means to provide observability from a business context, right? The criticality of being able to tie each of these to a business impact and give a view around whether it's a service level issue, whether it's an infrastructure level issue, make it completely transparent, right? That is kind of the first pillar that we talked about, right? Okay, let me talk about and shift gears around cross-melt, right? So we talked a bunch about what it means for us to be able to get data from different data types and bring that together. So think about the use cases here, right? If you look at many of the existing solutions, what we end up making our users to do is effectively respond to things like average response time, right? Or calls per minute, errors per minute. Bunch of metrics-based data based on which we trigger alerts and so on and so forth. At the same time, there might be some interesting events that are getting pushed out by the system, which are completely ignored, or there is an independent set of alerts that are configured for these particular areas, right? So what that forces you to do is effectively do one of two things. Either you sample only a specific section of data and ignore the insights that you're getting from others, and which increases your MTTR, or even worse, you are effectively alert noise, right? Bunch of alerts which are uncorrelated, but which are being caused by the same issue. All of those actually are now spewing out alerts. And that causes a problem, right? Because suddenly when you have alert noise there and you have alert fatigue, your SREs and DevOps folks are not responding to it, the ones which are most critical, right? So think about it, combined with what I talked about of being able to correlate this with business value and being able to see a wider spectrum of issues across events, logs, and traces, it allows you to really sharpen and pinpoint the actual root cause, right? So with that, a few key areas that we will talk about. One is, how do we capture infrastructure and service events? Two, how do we effectively do alerting such that data coming from not just alerting on metrics, but alerting on traces, logs, and events also come in, and they are correlated into a common alert, right? And lastly, of course, is there a way by which we can take advantage of native Kubernetes concepts around namespaces and deployments and use that as a filtering capability for these alerts, right? That is a super critical thing that comes out of the box as part of the product. That is cool. The second bit is, when you go deeper, how do you pinpoint issues through not just events, but through logs, right? Being able to go deeper, one idea is to get a common view across metrics, events, and logs, which you will see when I do the demo. But the more important thing is, if you want to be able to see details, if you want to go deeper in this, how do you surface key insights for troubleshooting using logs, right? There are complete products out there which only focus on logs and focus on log insights analysis alone. But the goal is, if for the same common entity model, if you're able to correlate all of this and bring events and logs data together and help you focus your RCA, there is great power in it, right? So going back to the cloud-native monitoring use case that we talked about, being able to get a fire hose of not just metrics data, but events and logs data, and being able to correlate that and capture it and discover log patterns and do interesting things like outlier analysis to give proactive alerting option, right? Today, one of the big things that we face as an industry is our alerts come too late, right? We are reactive to the situations. Customers talk to me all the time about, if there is a way by which we can get a pre-warning based on the fact that you see things like outliers, that would be extremely useful. What this capability allows you to do is do log pattern detection and outlier detection as part of logs, and really correlate that to a entity which is having an issue, so that you can give a warning saying, hey, these are the areas that need to be refactored all the way down into the code in order for you to be able to avoid this issue the next time around, right? So what that means is, with cross-melt troubleshooting, there are two key areas, right? You are able to derive insights from each of these different event types, and you are able to get to faster root cause analysis. But second, you are also able to start your journey on proactive and alerting. You don't have to wait for your issues to occur, but constantly, how do you improve the quality of your services so that service health and SLIs and SLOs improve over a span of time, right? That's really the second pillar. Cool. The third part, of course, is around how do we think around AI-assisted root cause analysis? Because all of this what we have done with pillar 1 and 2 is expanded the surface area of the amount of data that's coming into the system, right? As a result, if we rely on purely manual aspects of it, then configuring health rules, being able to configure all of this in terms of data management becomes a huge challenge. And that's where using AI intelligently can reduce the amount of configuration experience, gets faster time to value, and you can get to faster MTTD, right? So in order to do that, what we do is a couple of things, right? We focus on, obviously, cross-melt. If you haven't paid attention in all of these minutes, cross-melt, right? It's not focused on one event type or one particular data type. It's across all of these different data types. But really turn on anomaly detection, AI/ML-based anomaly detection, to discover cross-domain anomalies, right? So it's not an anomaly that affects only a Kubernetes environment, but what is the impact of that on the underlying service, right? Understanding cross-domain anomalies, and that too doing it out of the box using AI/ML, really helps speed up MTTR, right? And more importantly, we can, of course, configure health rules for every layer of the stack. But when you have a full stack view starting from the business down in there, what you want to be able to do is detect anomalies at each of those layers. So for example, if you detect anomalies at the BT layer, at the business layer, you want to be able to understand if it is caused by an anomaly at a lower layer, for example, at the infrastructure layer, right? Being able to detect anomalies in each of these layers using AI/ML, but also correlate each of those such that it's a related package that comes across, and it's a single incident rather than multiple incidents, is something that comes out of the box as part of this. And what that allows us to do is, going all the way back to that war room example that I gave you, is instead of having to rely on an actual virtual war room where humans are coming in and trying to figure out where the issue is, the system is able to guide you to follow the red and figure out exactly pinpoint where the issues are. And if there are multiple issues, what is the priority order of those issues? So cross-domain RCA becomes simplified, and the ML-driven insights at that point in time no longer become a nice to have. They become part of the institutional culture in the organization where they start relying on it, and you are able to automatically detect issues and figure out what it means for the overall business, right? So with that, we talked about 3 key pillars: business-focused observability, we talked about cross-melt troubleshooting, and we talked about AI/ML-based RCA, right? Now, I want to show a bunch of this as a part of a demo. I gave you a bunch of slides, but I want to show you as part of the demo. So a quick view on what the demo app itself is. Imagine that you're part of Acme Corp. It's a website that's allowing customers to purchase ebooks online. So the scenario here is it's an app, common app that you would expect built on Amazon EKS, multiple services as you would expect for an e-commerce, right? There's a logistics, a fulfillment service, inventory service, and an actual checkout process. The scenario is, what's happened is there's a new deployment. They do blue-green deployment in the company, right? There is a new deployment of the e-commerce service, and as a result, once that's been deployed, what users are seeing, or the business is complaining, the marketing department is complaining that checkout is broken, orders are being dropped intermittently, and the issue has come to Aparna, who is the DevOps person within the team running the services, right? What you will find out, I'm giving you this answer to begin with, is the root cause is really about Kubernetes pods crashing because of incorrect memory limits. So it's a fairly deep config issue, which is not observable at the top, but it's a reasonably common one, right? In Kubernetes environments, config experiences account for more than 60% of errors. So that's really at the heart of this entire experience. But it's a common blue-green deployment that we all use today in the way we deploy it, right? That's the troubleshooting use case. And you're going to see Aparna's experience as part of this demo. I'll have you pay attention to 2 things, right? I talked about business transaction insights. How do you correlate this for business? And second is that idea of continuous context, right? How are you able to keep all of this as part of the overall context in some ways, right? Those are 2 things for you to note down. Okay. With that, let me play the demo. Trying to get it started. All right. Okay, so what you're seeing here is a couple of things, right? I want to point out the AI features first. So as you can see on the left, this is literally the home screen. So let's say Aparna got that alert saying that, hey, there is a problem here. She logs in, and she's able to get a single view, as you can see, for the overall infrastructure, right? All the way from the service layer at the application performance layer down into Kubernetes and infrastructure. What I also want to point to is the health rules that you saw to the left in terms of anomaly detection. She sees that there is an issue with the service, and she double-clicks into the service view. To the right, you can see that it's the context of the service, and you see the entire dependency graph as part of it, and you're also seeing the red, right? The e-commerce blue service, the new thing that we just got deployed, that's showing red. So it immediately focuses her, and you will see that she can start exploring that, right? She can explore what are the different dependencies as part of this in a seamless fashion, and you can see that she can see each of the different service endpoints as a part of this, right? So let me pause this for a second. So what this means is in a single view, she got the overall view for it, and she was able to see, okay, there's a issue with the service, right? Double click immediately, and she's able to come in and say what are the various service dependencies, the different service endpoints. And if she goes ahead, what you would expect to see in things like that, you want to first check for the metrics data, right? You want to check if there is an issue with the average response time. And as you would expect, you're seeing some spikes in the average response time. And more importantly, you're actually seeing a place where even though the calls per minute is dropping, i.e., which means the number of orders that are getting fulfilled are getting dropped, the response time is peaked up, right? So the next part that I want to kind of focus on is, okay, so you've seen that there is a service issue. You want to be able to figure out two things, right? You want to be able to figure out, hey, what does it mean for the overall business? And two, then you want to go down and figure out what is the root cause analysis and how do you solve this problem, right? If you look and pay attention to the left side of the screen, in some ways, you get a lot of answers to those problems just by that left-hand view. And that's part of our continuous context experience, or what we call as hypergraph internally. It gives you a single view, and you can almost imagine, as I mentioned, in an organization, it could be multiple different teams which are involved in each of these, but they all get a common view as a part of it. So going forward, if you look at the overall services, you can see the fact that there are underlying pod and workload issues. There's a single pod, but single workload that's being served by multiple pods, right? You also get to see that there is an overall business context, and there are two business transactions that are also read, and that gives you a clue for it, right? So you want to find out what the context is, right? Rather than just trying to figure out what is the criticality of it. And we see, as you would expect, the checkout service has a problem, and a confirm order has a problem. That gives you the overall business context and saying, hey, look, these are critical, these are going to be impacting for the business, and it correlates to what Aparna heard from the marketing team, right? Makes sense? You can actually go deeper and actually associate dollar values or number of users impacted value in terms of business metrics for it. But that's really real for the SRE person to go solve that problem immediately. Go deeper into the business transaction, and you see the overall dependencies, and as you would expect, you are seeing the specific services that have an impact and their corresponding metrics. So even at a BT level, Aparna is seeing the same view that she's seeing from a services view, right? Which is that the ART is high. So she's done two things right now, right? She knows that there's an issue. She's gotten a full view. She already has a clue that it's an infrastructure issue, and she knows the business context for it, right? Using the continuous context experience and business transaction. So she wants to solve the problem again, and she goes deeper to figure out how she goes and solves the problem and really find the root cause for this. Remember, we know that it's a memory limit issue, but she doesn't know that yet. So she goes in there, she starts exploring deeper, and she goes deeper into the specific workload to figure out what the issue is. She's looked at the namespace, she's looked at the pods, and then she goes into the workload. I'm going to speed this up a little bit. All right. So she sees a few things, right? There are health violations going across in terms of the pods, right? That gives the first clue that there is a pod issue and the specifics on the pod issue. She can also see a couple of things. There are spikes about violating metrics, and it's a specific thing. It's effectively the pods that are getting killed off. And this is a very classic Kubernetes issue, right? If there is any misconfiguration of memory or CPU, Kubernetes tries to kill pods and restart them. And you can see that happen as a repeated pattern. And she scrolls down and she looks at, she has the logs view as well as the events view. The events view actually gives her a view. She has two different events there, as you can see. One is the out-of-memory kill events. That's a further clue that it's a memory limit issue, right? And that gives her the insight that, oh, okay, there has been a new blue-green deployment. It's a problem that pods are getting restarted. It's a memory limit issue, and when she zeroes in on it, she realizes that the memory has been configured too low. And that's enough for her to go talk to her release engineering team to go back the change that happened, and then also give feedback to the dev team to figure out how they refactor this configuration issue, right? This is what we can do with the product today. Very soon, we are also releasing a capability where this last step itself can be automated. We are planning to release a capability around infrastructure optimization, which will effectively take this input, optimize the infrastructure with human control, but using AI/ML so that even this last step can be completely automated, right? All right. So I showed you a quick view of two things, right? The overall business transaction concept, but more importantly, how do you quickly solve it and focus on what's important for the business? So with that, let me give you three key pillars as a final thought, right? What you saw here was the ability to get cloud-native visibility, right? Using not just existing proprietary agents, but using OpenTelemetry connectors. Being able to get insights which are contextualized with the business. And lastly, the single pane of exploration, which improves MTTR and MTTD, right? With that, you can get started with Dynamics Cloud today on AWS. And I will leave you with a splash video. And at the end of it, I'll bring Nirmal back, and we are happy to answer any questions.
Observing multiple cloud-native workloads in real time? That's tough. Modern systems have grown so complex, they're now beyond human scale. And that's a problem. Because any weak link in your infrastructure can bring your system to its knees, tanking your app and ruining your business. But it doesn't have to be that way. Welcome to AppDynamics Cloud, our groundbreaking cloud-native observability solution. Get all technical health data in one place. Visualize relationships dynamically. Analyze across silos. Understand root causes instantly. That's AppDynamics Cloud. Engineered for OpenTelemetry. Providing industry-leading Kubernetes troubleshooting. Designed to make collecting, accessing, and correlating data across various providers and containers delightfully seamless. So that you can create the sort of experiences your customers deserve and demand. That's how you shape the future of apps. That's how you observe what matters. That's AppDynamics Cloud.
Awesome. Let's give Sundar a nice round of applause.
Thank you.